Everybody and their mom wants an AI agent, but you can't have a reliable AI agent without evals. So I'm going to give a quick update on how everything went, starting 5 seconds. But then I'm going to get into what we ended up building, some lessons learned, and some excitement and eagerness to get started on the next phase. All right, stats. I finished reviewing the Claude Code scores as well as adding a new score. We have a total of around, it's more than these amount of test files, but we added around 100 tests, and there's about like 7 actually, LLM scores, and then a couple deterministic scores. I'll get into the difference in a second. And then the stats for the commit of this last push, 2,353 lines, 163 deletions. You'll notice a lot of the lines are from test. And as I've said in the past, this is a recurring pattern. I find myself spending way more time testing and kind of adjacent to that now in evals to make sure that when agents add code, when I make adjustments to the code base, as well as the prompts and context of LLMs, to the LLMs, things do not get worse. You can't trust the vibes anymore, people. You have to put your big boy pants on or big girl pants on and start writing some evals and start writing some tests. All right, so super simple, but what have we done so far? I have this agent pipeline. This agent pipeline is supposed to output problems, homework problems, let's say addition, and it should come up with new problems, and we want to verify that the problems are correct and that they're good and they're going to help the student learn. Well, how do we do that? Well, we can vibe test it, go through the problems, click through them and see how they're working, which will work, and probably how you're going to start your POC or your proof of concept, your POC, and just get comfortable with whatever agent you're working with and you're building. Now, I'll get into a little bit of detail of how I built my agent pipeline in a second, but first I want to run through the entire eval pipeline. This agent outputs generated problems. What is 1 plus 5? What is 8 plus 10? So on and so forth. And these problems are the things that you would surface to the user and vibe test with the UI. But in our evaluation framework, we need to make sure that we're actually judging the output of these problems and on a data set that we can continuously run, and a stable data set that we can continuously run, so that over time we can see the numbers increase in terms of whatever these scores actually score. So at the beginning, it might be really bad math problems or addition problems, and the scores may be really low. I find it hard to believe because LLMs are really good, but let's say if the math concepts were a little bit more complicated. But you also might be judging other things outside of the problem, like is it a unique problem? When this AI agent pipeline outputs a problem set, is it outputting the same problem over and over? What is 2 plus 2? What is 2 plus 2? What is 2 plus 2? That'd be really bad. And so we have another LLM judging that problem set blindly without seeing necessarily the input of what this agent saw, and just judging, given this list of problems, are they unique, or how difficult are they there, or what's the quality of the failed turns that you saw that the student made that informed you to create this problem, so on and so forth. So these are the LLM as judge scores. And then there's also deterministic scores. These are things that just can validate the actual, like deterministically via some code, the output. One simple one is like the schema and the format check. Others are maybe there's like keyword checks that you want to make sure you have inside of the question. Maybe every question in this generated problem set, you want to have either a what or why or some keyword. You can add a deterministic score that will just go through that and continue to report on it. Now, I actually think, I haven't put that much thought into it, but I think the deterministic scores you don't actually need. And the reason I say that is if you make this agent pipeline really solid, it should be able to verify any deterministic checks while the agent's producing. Otherwise, it should just fail, or can just fail, I should say. So we have all these scores, and they output to Brain Trust or pick your eval SAS, and then you can see on a nice dashboard the increase or decrease of performance as time goes on, which is really, really awesome. And so now I want to get into the agent pipeline and one of the motivations why I did this right now. So my agent pipeline for generating problems is, I actually don't consider it a true agent. It's more of like a probabilistic workflow. And what I mean by that is there is code that's running, and within the code, there are these probabilistic functions or LLM calls that take in a defined input, like for example, the lesson material, and are supposed to output a specific, a very specific thing that isn't necessarily the entire generated problem set, but an intermediate step. So I'll just get into the actual legitimate like code to show you what I mean very quickly. So there's like these 4 functions I have. I think it's a really simple. Actually, I might not go through this because it might be a lot of code to just go through really quickly. But the general gist of it is I have a bunch of these functions that. Okay, this is a function, yeah. I have a bunch of functions within the code that are each independent LLMs. And so, for example, one function might get a student misconception. That's from an LLM and outputs it into into the code. And then another LLM takes that misconception and figures out what's a good way to address this misconception. It outputs in a format that I defined different ways to address that misconception. I then feed that into another function that will generate a problem for the given misconception. And so I call this a probabilistic workflow because within the workflow, there's a bunch of LLM calls. You can also just call it a workflow with LLMs within it, but this is just the name I like because it sounds fancy. Now, I want to change this workflow because I actually think the agents, the latest LLMs like Gemini 3, Claude, should be able to generate the problem sets in actually better than in the deterministic wrapped probabilistic functions deterministic probabilistic mix workflow, or just the workflow. I'm just gonna start calling it the workflow, and that's because I think they're smart enough to figure out how to use tools if you give them the right tools more intelligently than if I were to just predefine a specific workflow and order that the LLM functions should be called in. And because of that, I want to try this more pure agentic approach where I set up an LLM, I give it the correct tools to collect the right context, and then at the end, all it's supposed to give me is a set of generated problems. Now, I can't make that switch, or I could, but I couldn't know for certain if that switch, when I make it, is actually improving things unless I have a way of evaluating the actual outputs. You see what we're doing here. And so because of that, I went through all the trouble of setting up these evals so I can now work on this pure agentic approach where it's going to be an LLM and some tools to output new problems, and then I can just rerun these scores on the outputs to see if, in general, the problems are higher quality or lower quality. And that's that. That's kind of everything. So what am I so excited about? It's really just the fact that I will see for myself, instead of just vibe testing, I'll see with actual data. Sure, LLMs, they're not deterministic, but it's still data, and it's more confident than just me looking at vibe testing it. How well this is actually going to increase the performance. Now, getting into a little bit more detail, how did I go about setting this up? I'm not going to get into the actual code specifics, but it's pretty simple. You just set up different functions. You break down the problem in different ways. Like I said, you try to, the example I gave is you find misconceptions, and then you address those misconceptions with solutions, and then you turn those solutions into problems, and so on and so forth. How did I get into making these scores? This is what I've spent the past week on, and it's kind of boring because not only do you set up these scores, like making sure that there's a unique problem solver. They look like this, where Let me find a good one right here. Unique problem solver. This is a score. It's just a function that says you're an expert educational content evaluator. Your job is to determine if every problem in the generated problem set is unique. If it is, output a 1.0. If it's not, output a 0. Pretty simple. And then and then based off that, you would see on the dashboard, a pass or a fail. Now, this is a pretty simple LLM and a simple prompt. But even then, if it makes mistakes, I need to know, and I need to know now rather than when I have 1,000 size data set or 10,000 size data set, and I'm running this and starting to trust it. And so what I've done over the past week is I've set up these different scores. I ran it over a sample data set, and then I would manually look over each of those samples to confirm the thing that the score was saying about the output is the same thing I would determine, i.e. that all the prompts are unique. Now, this truly is a very simple example, and none of these were wrong. There's more complicated scores, though, like quality of failed turn, right? So the making sure the LLM identified evidence in order to make this new problem. Another one was like optimal sequencing of problems, or the different types of problems that are within a problem set in terms of like the depth of knowledge. There's a bunch of scores, and those a bunch of non very simple like unique scores that involved setting up actual test for to confirm different edge cases. We're working with this with these LLM scores, or LLMs as judge, and along with that, I would then write the unit test and then verify within the dashboard, making sure that things look right on the sample data set. And so that's what I've done. I'm really excited for this week because this week's gonna unlock this approach. We now have the scores. We now have the evaluations running. I think I can probably get this done in a solid day or two, depending on how much time I have. The thing that's going to honestly take the longest with changing this is making sure I write solid tests for it. I think you're seeing a theme here if you've if you're watching, which is that you need tests and you need evals. Like even these scores, which are LLMs that judge another LLM, I have unit tests for these. Now I don't have evals for these, but who knows? Maybe that's the next step. Feels a little overkill right now at the stage I'm at. All right. Having said that, I'm gonna sign off for today. Review. I think I already said the stats, and so we're good there. But lots happened this week. Really excited about it. So much of it was just manual review, but it was just the elbow grease that was needed. I'm not done with these either. I still need to go back to create a larger data set, do some other fancy stuff as far as being able to generate that data set, along with swapping this pure agentic approach. But I think this is something that I can do quick enough that I will just do and see how the eval performance or scores change. All right, having said all of that, I will see you tomorrow.